two key outcomes for me are design holistically, think about the whole year efficiency, and collaborate with urban planners and local authorities to make your cities and towns greener and cooler as a microclimate, because that's what will allow buildings to actually open windows without getting the pollution in, without getting the noise in. So you allow the building to be efficient without having to put a lot of systems in it.
Welcome to the Green Urbanist, a podcast for urbanists fighting climate change. I'm Ross. Hello there, my guest today is Antonietta Canta.
I am Antonietta Canta. I work in Arup in the Applied Sustainability team. My background is in architecture, but I've been working as an energy engineer for the past 6.5 years at Arup, working mostly on thermal modeling, energy modeling, overheating and thermal comfort.
In this episode, we discuss Arup's recent research report titled Addressing Overheating Risk in Existing UK Homes. Now, I know that title sounds incredibly dry, but actually the conversation was very illuminating and useful. I sat down with Anto to discuss how many UK homes are at risk of overheating now and in the future due to climate change in different climate scenarios, why new apartment buildings overheat more than houses or older buildings, and the best strategies for reducing overheating in new and existing buildings, with advice for architects, planners and policymakers. Antonietta takes what is quite a technical subject for many people and explains it really, really clearly, pulls out all the key essential information from this really good bit of research and explains it all with a bit of a sense of humour as well, which is always welcome. If you're enjoying the podcast, remember you can support it by sharing it on social media, sharing it with a friend or a colleague of yours, and leaving a rating on the podcast platform that you're listening on. That really helps. If you're getting a lot of value from this podcast, you are also able to make a financial contribution. You can make a donation to the Green Urbanist podcast via the link in the episode description, and that really helps to cover the running costs. And plus, I give half of it away anyway to other organisations that are doing climate work in cities. At the moment, I'm supporting the organisation Trees for Cities, which is brilliant. And so, yeah, you get to support two great things at the same time. Otherwise, do consider signing up to the newsletter to get weekly updates and more content about green urbanism. But for now, enjoy the conversation between myself and Anto. So I've wanted to have you on because you co-authored a research report on overheating in the UK. Can you tell us a bit about where that came from, why you wrote it, that kind of thing?
Yeah, so it was the Climate Change Committee who appointed us for the work. It was an open tender, and they wanted to have a clear picture of what the overheating risk in existing UK homes looks like right now and what it would look like in the future, in future weather scenarios. So they wanted to understand what the risk is currently, what it would be in the future, but also what potential interventions could make it better in the current scenario and in the future.
Gotcha.
And most importantly, they wanted an understanding of the cost, the scale that mitigating the risk would imply. So how much would it cost for the whole country to do something against overheating risk? So yeah, it was a big task which we split into 3 phases, and we tried to address the different questions through different approaches. Yeah. Brilliant.
Okay. So why is this something that's important to be looking into? Just fundamentally, yeah.
Well, it's something that has been developing more and more in the latest years. It's important because it has implications on health and well-being of people. It has implication on how focused people are at work, but also how well they feel during the day generally. And especially in the elderly and more vulnerable people, it can have serious health implications, and people actually die when they're not in comfortable conditions, and they might have illnesses, or they are particularly old and disadvantaged. So UCL was involved in the project, and they were particularly keen to understand the implications on health and death rate of overheating as well.
Yeah. And what like, how do you define overheating as opposed to, like, what's a normal range of temperature and what's too much?
Okay, so when we look at what we call free running buildings, which means when a building can be operated freely by a person and the person is also able to adapt their clothing level freely, we use an approach which is called adaptive comfort approach, which is not based on specific temperature ranges and is depending on the outside temperature. So the principle is, if the outside temperature is higher, a person would accept a higher temperature indoor as well, because they would then dress up appropriately. If it's warmer, they will dress less. If it's cooler, they will dress up more with heavier clothes. So yeah, it's an adaptive approach that we've used, which is described in more detail in TM59, CIPSI TM59, which is the best practice guidance on how to assess overheating in domestic buildings in the UK.
Okay.
So we use CIPSI TM59 as our assessment methodology. However, it should be noted that this is a methodology that is designed for new buildings, to assess the overheating in new buildings which are being designed, and therefore it's very strict. So it's not exactly fit for existing buildings which have been designed 30, 50 years ago.
Yeah.
But it's the only one we've got available at the moment. So that was the only scientific way to assess overheating that we had.
Okay, brilliant. That makes sense. And there is sort of good, I think in the industry now, there's sort of good guidance and standards around overheating, isn't there? So I think as an industry, we're sort of upskilling and knowing sort of how to cover that more and more. Can we talk a bit about, well, I suppose, tell us about maybe some of the main findings of the report. How bad is it at the moment? How much worse will it get in future?
Yes, so we ran this modelling. I'll give you a bit of an introduction on the approach that we used to make it a bit clearer. So the question was to assess the overheating risk for every single home in the country, which we're talking about 28 million of homes in the UK. Obviously, we couldn't model every one of them specifically, but the approach that we adopted was to identify archetypes. So we had 6 archetypes, 4 houses archetypes and 2 flat archetypes.
Okay.
And we looked, basically we working with another consultant called Parity Projects. They had a stock model of the English housing stock, and we basically mapped how many of the English housing stock corresponded to a certain archetype.
Okay.
So we modeled, using dynamic simulation modeling tools, we modeled the 6 archetypes, and then we mapped the results to the whole of the English housing. Gotcha. And then we extrapolated the results to the rest of the UK based on the data that were available for the other regions in the country. So it was a bit of a kind of like applying results for a smaller sample of buildings to a much bigger sample of buildings.
Yeah.
So when doing that, we also selected multiple variables that would affect the overheating. So we had the archetypes was one variable. We also had the location. So we split the UK in 5 different climatic areas. And then we had different types of constructions and different orientations initially. And then we had the 3 weather scenarios. So by combining all of these variables in our modeling exercise, we were able to model 2,400 case studies, which were kind of representative of a portion of the UK housing stock. So by doing this modeling, we realized that the problem is particularly significant in London at the worst, and then followed by all of England, which is actually quite warm. And then followed by the Midlands, and in last position we have Scotland. So London and England are currently already experiencing a really strong overheating risk. while in the 2 degrees global warming scenarios, we see the Midlands also suffering from severe overheating. And in the 4 degrees global warming scenarios, the problem gets to Scotland as well. So this is how it works. In terms of the percentages, we've seen, based on the TM59 approach, the current weather scenario, we have about 55% of the housing stock overheating.
Wow. Already?
Already.
Wow.
Yes. In the 2 degrees, we'll have 92% overheating. And in the 4 degrees global warming, we will have all of the buildings, 100%.
Yeah.
So that's how bad
incredible.
it is. Yes,
Yeah.
yes. In terms of the main findings, I guess archetypes were one of the things that obviously made a big difference. So flats are definitely more prone to overheating than houses. And the reason for this is the fact that basically substantially overheating is dependent on the size and the density of occupancy. So the smaller the flat, the smaller the space, and the more people in it, the worse the overheating risk.
Right,
because
okay.
you'll have internal gains, you'll have heat produced by the people.
Right. So overcrowded flats.
Overcrowded, yes.
Yeah, like you have in London and big cities. Would
Exactly.
be more at risk.
Yes.
Okay.
While if you have a big house, 5-bedroom house with 3 people living in it, you'll have plenty of space and plenty of air to kind of recirculate and reject the heat outside.
That makes sense. Well, I mean, it sounds like, it's obviously a simplification, like the kind of modelling of the reality, but it does sound very robust in the sense that you had all those variables taken into account. What could you not take into account, or what do you think were some of the things missing in the modelling?
There were loads of them. So we tried to do as much as possible and to expand the sample as much as possible, but obviously it was a big challenge. Yeah. Some of the things that are still quite important that we weren't able to model were the impact of noise and pollution on the ability to open windows, for example.
Right,
so the results would be even worse if we apply those conditions as well. So, for example, in London, there's many places where windows are not even openable because the area is too noisy or too polluted. So in the design phase, it wasn't even considered possible, and openable windows were not even provided. So in those flats, the overheating risk is much, much higher. Another thing we didn't consider was the impact of adjacent buildings and how they overshade the building that we were analysing. So that, on the contrary, would make the risk a little bit lower, potentially, because the shading would help. Also, we had to model the user interaction with the building in one single way.
Okay.
While obviously every person interacts with their building differently. Yeah. So there was a number of simplification, which obviously were all listed in our report, but we tried to find the most standardized way to kind of cover a bigger sample of buildings as big as possible.
And I guess the other thing is things like vegetation and trees, which obviously would have a beneficial impact on cooling if they're in the right position. Yeah,
definitely. Yeah.
So do you think in that case that the numbers that you've suggested in terms of the percentage of overheating, do you think it's a bit of an overestimate or a bit of an underestimate, or you think maybe it's about right? It's hard to know.
It's really hard to say because we don't know. We don't have any information about how many homes are restricted in opening their windows. We don't have any information about how many people live in the places. So I don't know. I think our guess could be plus or minus 30%. Okay. But I think that the most important thing that came out of the report is not necessarily about what is the exact number of homes that are actually suffering from it, but what are the key things that you can do and we should do to improve the way we design building or retrofit buildings. Yeah. So how much impact a certain intervention can have in reducing the overheating risk, and what are the most effective interventions.
So you in the report, you kind of quite helpfully give advice for several different actors, so architects, planners, policymakers, etc. So why don't you tell us, I suppose, some of the key things you'd suggest to people?
Yes, so I guess in terms of the design, so what architects and engineers could do, one of the key things that we would strongly recommend in general, the general approach should be when you design a building, especially when you retrofit a building, you should look at the problem in a holistic way, and you should consider what is good for efficiency in like all year round. So what is good for summer comfort, what is good for winter comfort, but also what is good for efficiency all year round. Because typically, especially the newer buildings, which are, by the way, the ones that have the biggest problem. So the newer the building, the more they overheat.
Really?
Yes.
Oh, that's
especially
surprising.
for flat.
Wow.
And the reason is because our building regulations are focused on improving energy efficiency. But what we traditionally consider energy efficiency for dwellings is retaining the heat.
Yeah, okay.
And not letting it go anywhere. So we basically try to over-insulate the buildings, but on the other side, we do not give enough importance to the ventilation and having big enough windows that you can actually open and basically reject the heat when you don't want it inside. So for designers, the key consideration is please make sure that you consider the whole year. And I think if we really want to solve the problem and still not make worse the carbon emission problem and the energy efficiency problem, we should really change drastically the way we design buildings, especially flat. We shouldn't be seeing any more single-sided flat. We really need cross-ventilation in our flat and have windows at least on two sides, whether it is two perpendicular sides or it's cross-ventilation, but still at least two sides. And the other thing is we see a lot of new buildings which have massive glazed areas. But of those glazed areas, most times you have only like 25% that can actually be open. So you get a lot of solar gain inside, but you have no way of letting this heat out. So again, reducing the glazed area, increasing the openable area is really key. And also external shadings is really important. We've seen that external shadings are possibly the most effective way of reducing overheating. However, there's some side effects, let's call it, because obviously external shadings, especially for high-rise building, they have quite a high embodied carbon at the moment.
Oh, really?
Especially, yes, because for fire regulations, you can't really have anything else than aluminium on a high-rise building if you want to make it shaded from the outside. So obviously the embodied carbon is quite high. So you should really try and maximize the ventilation side of it so that you don't need as much shading as you would otherwise. So using also like natural shading devices, having trees. And another really important thing is reducing the urban island effect. So we saw that London is by far the worst place to live in terms of overheating. And that's because we don't have vegetation. And if you go outside of the urban area, that the temperatures go down by even like 5 to 7 degrees in a single day. So I think it's really important. So the two key outcomes for me are design holistically, think about the whole year efficiency, and collaborate with urban planners and local authorities to make your cities and towns greener and cooler as a microclimate, because that's what will allow buildings to actually open windows without getting the pollution in, without getting the noise in. So you allow the building to be efficient without having to put a lot of systems in it and still be comfortable.
I'm really glad you brought that up, because I guess it's easy to focus this on an architectural intervention. But actually, I mean, there's so much to be done around the urban heat island, and the fact that our default road surface is asphalt, which is about, the material that heats up the most of any sort of paving material. It's black. It has a rough surface. It absorbs that heat and then releases it, later in the day. And so I think having a more holistic thought process around, paving roads and paving streets in ways that can have a cooling effect should also be considered, I guess, as part of this.
Yes, absolutely. I think that's probably the most effective intervention that we could put in place, because we are thinking about overheating and how we can solve it, and we always put the responsibility on the architects and the engineers' shoulders.
Okay.
But actually sometimes we can't really achieve the goal because there's a planning condition that says you cannot open the windows because it's too noisy or it's too polluted outside. So it's that we can't achieve comfort unless we put cooling in those circumstances, which is obviously really bad for the environment. It's going to create more carbon emissions, and more importantly for overheating, it's going to reject more heat outside, which is going to increase the temperatures of the environment. So it's kind of making it worse and worse and worse in time. So we really need greener cities and cooler cities so that our buildings can be cooler inside.
You're from south of Italy.
Yes.
I'm sure, you've been dealing with potential overheating for centuries in different sort of passive ways. What sort of lessons do you think we can learn from Southern Europe?
Well, there's a number of different things that makes comfort perception very different in the southern countries. So I think we are more used to heat and we tolerate higher temperatures in general because we've grown up resisting to 42 degrees in summer. But I think also cities were designed and planned differently. Roads were much smaller so that building would overshade each other. External shadings are a must in most Mediterranean countries, and that's why I really think we should really change the way we look at building design. And sometimes it's a cultural barrier, which we need to get over at some point, because our climate is getting closer to the Mediterranean one. Our design should get closer. But also I think sometimes it's about how you manage a building. Like I remember when we had the heat wave last year, most people in London would just open their windows all day. And that doesn't work. And we know it, like in the south of Europe, we know that you have to close everything you can close, all shutters and blinds and windows are closed during the day and then open at night to allow the cool air to come in. So I've said this during a conference before. I think for designers, but also for occupants, go to south of Europe, have a look around and see how people use the buildings, how people design the buildings, and try and learn some good, important lessons from there. It's quite important, I think.
Yeah, that's really interesting. And I think what, the visual I always have in my mind from visiting France and Italy is the wooden shutters, probably painted a beautiful colour. And it's just the simplest low-tech solution of just opening and closing wooden shutters external to the windows. It sounds like on certain buildings, maybe that is for fire regulation reasons, you might not use that, but presumably on houses or low-rise buildings, that could be adapted easily in the UK.
So on houses, you can definitely use the Mediterranean shutters. That's definitely allowed. On higher buildings, there are other ways, like in high-rise Italian buildings, for example, you have the roller shutters, which do not create, as far as I'm aware, do not create a particular fire risk, especially because normally they are in PVC, so it's not really a inflammable material. But again, it's a completely different way of detailing that window and that specific part of the building. So it needs a change in the mentality, potentially in the regulations as well. So we need to work closely with fire engineers and other specialists that are not necessarily architects to understand how we can overcome some issues that might be different from other countries. Yeah.
Well, I think there's one thing is the cultural aspect of like people getting used to maybe our buildings looking a bit different. But I suppose the message is that, our traditional buildings that you see around England and the UK, developed within a certain climate. And that climate is now changing. So it's natural that we would have to make adaptations to that. So I think there's something we have to get over there.
Yeah.
But I think in terms of planning and regulations, there's a couple of really simple things I think the government could do if they really wanted to just make it really simple for people to adapt their buildings. So, there's something called permissive development rights, which in the English planning system means there's certain things the government just says householders can do without any planning consent, basically. And usually it's like small extensions or things like that. They could easily just include, make an amendment to that legislation to say external shutters, the same dimensions as the window opening. You can do it, no planning permission needed. Just go ahead and do it. And then they could even provide a certain type of design code to say, they should look generally like this if they were concerned about the aesthetics of it. So I think there's probably quite simple things we can do to make it really easy for people.
Yes, no, definitely. And there are some examples. If you go in like old towns or villages, sometimes you do see something that on a first look they look like external shutters, but actually they're fake, so you can't actually move them inside. So they are just open outside and they look like shutters. So I think that's one thing that on houses especially is not necessarily something that the average British person would particularly find particularly strange.
Okay.
But yes, it doesn't get usually specified in our building design. So there's more steps that we can take to make our buildings better. Even like when we look at like high-rise building, we always see these like full-height windows that don't really help in terms of daylight. They don't help in terms of privacy. But it's just the way we are used to look at the design of a high-rise building, and that can easily change. It's just up to the architects to just look at things differently.
Starting the design process by thinking about
sustainability
and thermal comfort, and then getting onto aesthetics after that, maybe, rather than starting with an aesthetic style and then trying to like retrofit back in.
Yes, and I guess it's about the references as well. Like the process architects normally work is they have a few references that they take inspiration from. There are references out there, if we look a bit wider than the UK, where you can find really good examples of architecture that are actually good for the overheating and the comfort in summer. So it's just about looking somewhere else.
The other thing I wanted to ask you was what interventions did you model that you actually found weren't that helpful? Or was there anything that was surprising in that?
So we did model a few. In the report, you will find a very nice graph which shows the reduction in overheating for every single measure that we tested.
Okay.
So some of the less effective ones were, for example, the reflective paint on walls or for flats. And while they had a big impact or a good impact on houses, in the flat, they didn't really help that much, and that's because obviously the surface of the wall compared to the surface of the floor was much smaller in a flat, so those interventions weren't really that effective. And also there were some interventions that we called like easy wins, but which were cheaper and also less effective. Things like reducing the G value of the windows by just applying some additional films, the ones that you can buy on website or in the supermarket. Things like that weren't particularly effective. But one intervention that actually does make a difference and probably is quite underestimated is the use of fans. So either ceiling fans or floor standing fans. That's actually quite helpful, because even where you don't have a particularly effective ventilation, your windows are small or you don't have cross ventilation, they can really help move that air around. And also you have the evaporative effect, which makes you perceive a lower temperature, even though the air temperature might not necessarily be lower. So that was kind of one of the surprises. And another point that was quite interesting was when we modeled the effect of insulation, especially on walls. And at the beginning, when we modeled the whole housing, the whole modeling sample of 2,400, we couldn't really identify any trend on whether the insulation was helping or not. It looked like it was the results were kind of stable and not varying that much. And then when we looked into the more detail, we realized that the reason was that the impact of insulation is very different depending on whether your ventilation is good or not. So what we found is that if your ventilation is effective, by adding insulation on your walls, you actually reduce the conduction gain. So you reduce the external temperature of the wall, and therefore less heat comes in through conduction.
Yeah.
and you still have the windows to kind of release that heat outside. While if your ventilation is not good enough, for example, in the case of small flats with small openable windows, your insulation will reduce the ability of the heat to leave the space. So it will actually make the overheating worse. And that was one of the key really important points that was important for us to say, like, you have to really think about retrofit holistically, because recently we are trying to do a lot more in terms of housing retrofit, but we normally tend to just add insulation and that's it. And sometimes we don't even check what the ventilation rates are, whether we have enough ventilation to get rid of the heat in summer. And that's going to make the problem worse and worse for existing buildings. So it's really important that we model the building as far as possible. It doesn't have to be dynamic simulation. It can be through Excel calculations or like steady state calculation. But yeah, make sure that we have enough ventilation to get rid of the heat in summer.
And something like cross ventilation will help with that, obviously.
Yes, exactly.
I think of like a passive house standard that is all about air tightness and very, very heavy insulation, and all about keeping the internal temperature stable, throughout the year. Are they achieving that? I guess they're achieving that through mechanical ventilation then, or how does that work?
No, so that's a misconception about passive house. So passive house, the objective of passive house, the reason why I invented passive house was to have a house which almost wouldn't need any heating at all. So they wanted to keep the heating demand and the peak heating demand under a certain level, so that it could just be the lever. So you could have a comfortable temperature indoor just by recovering the heat from inside the room. Okay. And during the winter time, you want your building to be absolutely airtight and have no other air coming in other than the one that goes through the mechanical ventilation with heat recovery. Okay. However, in summer, you want windows to be open. Yeah. So for a passive house building, it is actually very important to have big openable windows so that you can cool it down during the summer. And that's exactly what I was saying earlier. So having a very insulated building is good if you make sure that your windows are big enough for the summer comfort as well.
Okay, that makes sense.
So I've mentioned already that our study was based on a number of assumptions and limitations which are related to the impossibility of modeling noise and everything. Exactly. Another important point is about the assessment methodology. So as I mentioned, we use the 60 and 59, which is based on two criteria. One is based on adaptive comfort, which applies to all rooms in the dwelling, and the second one is based on a fixed temperature limit, which applies to bedrooms at nighttime. Okay. So this second criterion is actually the one that is responsible for the highest percentage of failing in our modeling exercise. And it's also the criterion that makes a lot of the design projects fail. And because now we have Part O, Building Regulation Part O, which is actually based on 1059. So if you don't pass Part O, you can't build your building. Okay. So basically you have to try your best to achieve Part O through passive design. But if you can't, then because, for example, it's too noisy outside or too polluted, you'll have to install cooling. What we've found, so we did this project in collaboration with Loughborough University, Professor Kevin Lomas, who is one of the maximum experts in overheating in the UK. And he was already in the process of reviewing this second criterion of TM59, which is thought to be based on a sample of experiments that was considered too small to be scientifically significant. So Loughborough University is actually undertaking some research, and we are also supporting them in updating this second criterion of TM59. So it would be interesting to review the whole exercise using the new criterion and see whether there's well, the numbers will definitely change, and by how much, that would be interesting to see. Because the new criterion we are working on is based on what is the number of nights in a year which is acceptable to have a mean temperature above a certain level, rather than a peak temperature, which is the current criterion. Yeah. So yes, it'll definitely be less restrictive than the current criterion, and we could see those numbers drop quite drastically if we were to test the new criterion.
Okay, interesting.
So,
Yeah, it really depends what your sort of standard and your level that you're checking is.
Yeah.
But I guess the overall message is probably the same in the sense of most of the stock of the UK is ill prepared for rising temperatures.
Yes, and I think we've seen the effects on our skin quite clearly in the last couple of summers. So yes, we need to be prepared. We need to change the way we approach building design and retrofit, definitely.
Okay, interesting. I think the other thing you said was around the cost of retrofitting. Was that part of the study as well?
Yes, so what I didn't mention is when we looked at the interventions, we assessed a few interventions singularly, so one by one on a couple of examples of archetypes. And then we grouped them together into packages. So we had 5 packages going from package 1, which was the easy win, what we called it.
Oh, yeah.
So the cheapest and less effective interventions, all the way up to package 4, which was the passive or low energy interventions that were more effective and more expensive.
Okay.
And then we had package 5, which was cooling. Wherever we couldn't achieve the actual comfort according to TM 59, we would actually install cooling. So when we calculated the cost, the numbers are quite scary. For the current weather scenarios, achieving a full pass on TM 59 would cost about 245 billion to the country.
With a B, billion.
Yes. And in the 2 degrees global warming, that would go up to 560 billion.
Wow.
So this is for the 2 degree global warming. For the 4 degree global warming, the cost is slightly lower. And the reason for that is because you need more cooling, which is less expensive than some of the passive strategies. So
really?
In order to achieve the TM59 criteria, you can't do it just by passive design. You have to install cooling, and if we were to install cooling on every house that would need it, we would get to about 490 billion, sorry. So it's massive numbers. It's like 20 financial plans from the government altogether. So if you were to do this using that budget, you would need 20 years to get there.
Wow.
So obviously it's not something that is feasible. We need a collaboration between the public and the private sector. But also some of these costs, a good proportion of this cost, is not necessarily just related to overheating, but it's also cost that you would incur anyway if you were to retrofit the building, or sometimes, for example, if you have to replace a window because it's old or because you don't like it anymore. Having a better performing window would only cost an extra bit, but it wouldn't be the whole cost of the intervention. So again, there's some limitations and some efficiency that could be achieved by, for example, retrofitting a whole development at the same time or a whole row of houses all at the same time, while in our analysis we didn't have those numbers, that data, so we just considered each unit as standalone.
Sure, that makes sense. Yeah, it's quite staggering. I mean, that's even much higher than the estimates I've seen for retrofitting for warmth in the winter, basically.
Yes.
And I think the other thing, I suppose the one thing to take away from this is that, it probably won't happen in the sense of retrofitting every building, every home. But maybe it'll be a starting point for prioritizing, and maybe the government or however, philanthropic people can prioritize, funding vulnerable people or people, older people, retirement communities, things like that, where I guess you'll have the most potential, sort of life-saving potential from those interventions. Yeah,
no, absolutely. It has to be a joint effort, and it has to be a strategic effort. We have to think about retrofit at scale, and we have to think about retrofit for different things. So we have to think about retrofit for fire safety, for accessibility, for overheating, for winter efficiency, we have to put all these elements in one single equation. We can't keep looking at each problem separately, because, again, it won't be efficient in terms of like the outcomes, and it won't be efficient in terms of the cost, because you will be doing something that might be good for one aspect, but that actually make another aspect worse. So you have to really think about the whole scheme of things, and do some sort of like multi-criteria analysis to understand what are the solutions that have the best impact on a higher number of aspects, rather than just split the problems in smaller bits. In this situation, it doesn't really work.
Another interesting aspect of this is the embodied carbon emissions in all of that extra material, that you're putting on buildings, whether it's insulation or shading or that kind of thing. And I think that's a consideration as well. I appreciate you haven't quantified that, but I think it is a give and take, isn't it? It's like you're sort of almost investing emissions and energy up front to save emissions later, in the sense of avoiding using air conditioning and things like that.
Yeah, so that's a really good point, especially when we think about energy efficiency for winter. In the case of cooling, though, if you don't do the passive strategies, you will almost certainly end up having people buying air conditioning units. And the embodied carbon of refrigerants is one of the biggest portions in the building services embodied carbon equation. So by adding a bit of extra insulation, or using openable windows instead of non-openable windows, you might have a little bit of increase in your embodied carbon, but you might be able to save a whole piece of equipment for cooling. So every design is a different story, and obviously solutions are not universal, and there's no one solution that works for everything. But it's really important. The holistic approach, again, is not just about winter and summer. It's also about doing whole life carbon assessments when you do a new building or a retrofit intervention, and really understand what is the impact of different solutions. It's about really experimenting new ways of designing a building, rather than just going along with our traditional way of doing things, and make sure that we actually consider all the factor in the equation, and we compare different options, and we do the optioneering, which is so important in the design process.
Yeah, and I think the other thing as well that's an interesting exploration is behavior. How will we adapt our behavior and our social norms around a changing climate? Because there's been a lot of talk the last 2 summers in the UK about the fact that there's no law, like there is in other countries, say in Europe, about a maximum temperature that people are allowed to work in. So I think in various European countries, there's a figure, whether it's 35 degrees Celsius or 37 degrees, or I can't remember off the top of my head, where people are not allowed to do outdoor work anymore. So people, construction workers and that kind of thing. And we don't have that in the UK because it hasn't been a problem until now. But I think there'll have to be conversations around not only when is it okay for people to work outside, but actually when is it okay for people to work from home or from their office when it's overheating, in the afternoon in August, and it's like really uncomfortable temperatures. I think we'll have to adapt our sort of social norms to say, actually, it's not okay for people to sort of be stuck inside during a heat wave, writing reports and stuff.
Yeah, no, that's a really good point. And to be fair, well, my dissertation and my master was on overheating as well. It was about overheating in an office building, and one of the intervention that I recommended was to have a longer lunch break. Potentially a bit later in the afternoon. And that's what we do in Italy most of the time. Not so much anymore, but in the past, especially in the south, you would have a big lunch break from 1:30 to 5, for example, which is the actual hottest part of the day.
Yeah.
Where you can go home, or you can go to the park, and you can just stop working and get cooler, and then you come back to work, obviously, at 5, and you then work until 8 or something, which is very different from our arrangement. And also in south of Italy, we have a long break in summer, which every company kind of shut down because it's just too hot to work. So There are things that can be done which, again, do not relate necessarily to building design and can really improve the way we work and the comfort environment, yeah.